Good morning friends, welcome back to our YouTube channel. Today we are continuing the problems on the chapter 10. Now let us consider first problem. In a double slit experiment, the light of the wavelength is 600 nanometer. The light of the wavelength is 600 nanometer. Is used. Find the phase difference and the path difference. Here we have to find the phase difference and the path difference. First one, we have to calculate here the fourth right fringe. We have to find here fourth right fringe. Second one, fourth dark fringe from the central fringe. First here in this condition, first we are writing the given terms what they have given. Let us consider the light of the wavelength 600 nanometer. Lambda is equal to 600 nanometers. And they are asked to find the phase difference and the path difference. Okay. Now let us consider first one, a fourth bright fringe they have given. We are considering small n is equal to 4. N is equal to 4. That is fourth bright fringe. Now in the first condition, we have to find the phase difference. The phase difference formula is 2n into pi. The phase difference formula is 2n pi. Put the value 2 into n, 4 into 3 point, or let us keep as it is pi. Now total answer we are getting as 8 pi. This is the fourth right fringe. We are getting the answer phase difference is equal to 8 pi. In the same way, for the fourth right fringe, we have to calculate the path difference. Therefore, the path difference the formula for the path difference we are considering 2n lambda by 2. Put all the values here. 2 to get cancel the term. Next n into lambda. N means 4, lambda means 600 nanometer. The calculation part for the path difference we are getting the answer as 2.4. Here 10 raised to minus 6 meter. 10 raised to nanometer is there. 10 raised to minus 9 meter. The total answer we are getting has 2.4. 2.4 into 10 raised to minus 6 meter. Now in the first condition we have to find the fourth bright fringe. For this we are finding the value of the phase difference and the path difference. Therefore the value of the phase difference is 8 pi and the path difference is 2.4 into 10 raised to minus 6 meters. Now next we have to calculate second one, that is fourth dark fringe from the central fringe. Here also again we have to find one is your phase difference and other one is the path difference. Now let us consider n is equal to 4. Now the formula for the phase difference 2n plus 1 into pi. For the dark fringe from the central fringe we are considering the formula. Put the value 2 into n, 4 plus 1 into pi. 8 plus 1 into pi. Total answer is 9 pi. The value for the phase difference at n is equal to 4 in the dark fringe. In the same way we have to find the path difference. Path difference. The formula we are considering 2n plus 1 into lambda by 2 for the path difference. Put the values 2 into 4 plus 1, lambda means 600 into 10 raised to minus 9 divided by 2. Now they cancel the term, 2 1 ja 2, 300. 8 plus 1 into 300 into 10 raised to minus 9. Therefore, the value of the path difference from the dark fringe to the central fringe. We are getting the answer as 2.7 into 10 raised to minus 6 meter. 2.7 into 10 raised to minus 6 meter. Now next question, second question. In a Young's double slit experiment, the distance of the screen from the slit is 1 meter and the distance between the slit is 1 millimeter. Here first they have given from the slit is 1 meter and the distance between the slit is 1 millimeter. If the third dark fringe is formed at a distance of 1.5 millimeter from the central point on the screen, calculate the wavelength of the light used. Here we have to find the wavelength of the light used. Lambda is equal to question mark. See here, first let us consider. Now first write the given terms what I have given. Now let us consider d is equal to 1 meter. D is equal to 1 meter. And the distance between the slit is 1 millimeter. Small d is equal to 1 millimeter, or it can be written as 1 into 10 raised to minus 3 meter. And they have told that the third dark fringe is formed at a distance of 1.5 millimeter. X is equal to 1.5 millimeter. Convert answer into meter. 1.5 into 10 raised to minus 3 meter. Now from this we have to find the value of the lambda. Lambda is equal to question mark. Now according to this they have given that third dark fringe n is equal to 3. Third dark fringe n is equal to 3. Therefore the formula we are considering has lambda is equal x is equal to 2n plus 1 into lambda d by 2d. The value we are considering x is equal to 2n plus 1 into lambda d by 2d. Here we have to find the value of the lambda. Lambda is equal to question mark. Now by according to this we are finding the value of the lambda. Now let us put the values. X is equal to 1.5 into 10 raised to minus 3 is equal to 2 into n. We are taking third dark fringe plus 1 into lambda is equal to question mark. Capital D is 1 meter divided by 2 into small d. 1 into 10 raised to minus 3 meter. Now next the calculation part. We are getting the answer as 1.5 into 10 raised to minus 3 is equal to 2 into 3 6 plus 1 into lambda by 2 into 10 raised to minus 3. Now total answer 1.5 into 10 raised to minus 3 is equal to 7 into lambda divided by 2 into 10 raised to minus 3. Or this can be also written in the form of or lambda can be also written as lambda is equal to 1.5 into 10 raised to minus 3 by 5 into 2 into 10 raised to minus 3. Now the calculation part of the lambda, we are getting the answer lambda is equal to 6 into 10 raised to minus 7 meter. The value of the lambda. The lambda we have to take in the nanometer. Therefore, lambda is equal to 600 nanometer. Therefore, the value of the wavelength. Here in the question, calculate the wavelength of the light used. Therefore, the wavelength of the light used lambda is equal to 600 nanometer. Now next question. In the Young's double slit experiment, the distance between the slit is 1.2 millimeter and the distance of the screen is 0.75 meter. If the fifth bright fringe from the central fringe on the screen is 1.8 millimeter, calculate the wavelength of the light used. What will be the distance of the fifth dark fringe from the center of the screen? Here first we have to write the given term. And here they are told to find what is the distance of the fifth dark fringe. Okay, small d we have to find, and again they are asked to calculate the wavelength. Lambda is equal to question mark, and the distance of the fifth dark fringe we have to find here. Now according to this, first we have to write the given terms. Next, writing the given term, lambda is equal to question mark, d is equal to small d is equal to, we are considering 1.2 millimeter, or it can be written as 1.2 into 10 raised to minus 3 meter. Next, capital D is equal to 0.75 meter. Next, x is equal to, we are considering 1.8 millimeter. Convert answer into meter. Now next we have to find here, calculate the wavelength of the light used. Okay. Now consider the formula x is equal to n into lambda into d by small d. Put the value n is equal to, we are considering the fifth, n is equal to 5 of fifth dark fringe. Now x is equal to what is there, 1.8 into 10 raised to minus 3 is equal to n 5. Wavelength lambda is equal to question mark, capital D is 0.75 divided by small d, 1.2 into 10 raised to minus 3. Now the calculation part of the lambda, we are getting the answer lambda is equal to 5.76 into 10 raised to, we are getting the answer as 10 raised to minus 7 meter. Or this can be also written in nanometer. Lambda is equal to 576 nanometer. In the first question, you have to calculate the wavelength of the light used. The wavelength of the light used, lambda is equal to 576 nanometers. Now next, we have to find the distance of the fifth dark fringe from the center of the screen. Therefore, we are considering the formula x is equal to, the formula we are considering x is equal to 2n plus 1 into lambda d by small d. We know all the values, just we are putting the values, and from this we can calculate the value of the x. Therefore, x is equal to 2 into n. 5 plus 1 into lambda is equal to how much? Here we are find 576 nanometer into capital D 0.75 divided by small d. The value of the small d is 1.2 into 10 raised to minus 3. Therefore, x is equal to 2 into 5, 10 plus 1 into 576 into 0.75 divided by 1.2 into 10 raised to minus 3. Or this can be also written in the form of x is equal to 11 into 576 into 0.75 divided by 1.2 into 10 raised to minus 3. Therefore, the calculation part of the x, we are getting the answer as 1.62. The total answer x is equal to 1.62 into 10 raised to minus 3 meter. X is equal to, answer is 1.62 into 10 raised to minus 3 meter, or this can be also converted into millimeter. 10 raised to minus 3 is there, this can be also written as x is equal to 1.62 millimeter. Therefore, in the question, first we have to calculate the wavelength of the light used. The wavelength of the light used, lambda is equal to, we are considering 576 nanometer, And again in this question only we have to find the distance of the fifth dark fringe from the center of the screen. Here therefore the distance of the fifth dark fringe from the center of the screen x is equal to 1.62 millimeter, or this can be also written as 1.62 into 10 raised to minus 3 meter.